Here's a last question that we're going to do with fundamental counting principle and some really nasty conditions. Okay, so we got Anne, Brian, Colin, Diane, and Eric. 5 friends going to watch a movie, and they're going to sit all next to each other while they're watching this. But now let's throw the conditions on here. The conditions are, oh, guess what? Aw, Brian wants to sit next to Diane. Aw, they must be dating. Aw, you're so sweet. Okay, stop. All right, so Brian has to sit next to Diane. So think about it. You have 2 possibilities here. You have Brian that can sit first and then Diane, or you can go Diane and then finally it's Brian. So if you think about it, out of this, you have 2 possibilities for that. Oh, that's interesting. So every time Brian and Diane show up, they have 2 possibilities. So my next question then is, what else do we have left? If we dealt with 2 people and we have 5 friends, we have 3 people left that we have to deal with, right? So if you think about it, Brian and Diane could be in the first seat right here, right? Or the first 2 seats. There's Brian and Diane in the first 2 seats. Then think about it. One of the 3 friends can be here, followed by another friend, followed finally by the last friend sitting in that arrangement. So Brian and Diane can be up front, and remember there were 2 possibilities for their arrangement. Brian and Diane, or Diane and Brian. Okay, but what if Brian and Diane want to sit 1 seat over? So that means they want to sit here. Okay, well, you still have Brian and Diane. That's still 2 possibilities there, right? Either Brian and Diane or Diane and then Brian. And then you still have 3 choices for this one, 2 choices for that one, and 1 choice for that one. Watch again now, because Brian and Diane are going to move again. Ah, they're just never happy unless they're moving. There we go. So we have 2 choices for them, right? So 3 choices for the first seat, 2 choices for the next seat, 1 choice for the last seat. And then finally, the last arrangement we can have, again, is Brian and Diane at the end. Now they're way over on the right side of the row. Okay, whatever. So you still have 3 choices here, 2 choices here, 1 choice for here, and of course 2 choices for Brian and Diane or Diane and Brian. Now, multiply these guys out. When you multiply these guys out, think about it. 2 times 3 is 6. Times 2, you got 12 arrangements here. You got 12 arrangements here, 12 arrangements here, and 12 arrangements here for a total of 48 possible arrangements. Yippee skippy. Now, let's take a look at one more kind of rendition. Very, very similar. Very, very similar. Think about this. Anne refuses to sit next to Eric. Well, how do we go about doing this? Do we start putting Anne 1 here and then choices for the other ones and so on and so forth? Well, you could, or you can use something called, watch this, it's called the complement. Okay, so in other words, start with Anne sitting next to Eric. Start with Anne sitting next to Eric and go through all the possibilities. Well, guess what? We just did. We did it right here with Brian and Diane. Now we'll do the exact same thing with Anne and Eric and say, yes, let's force them to sit together. So that means we have 48 arrangements of them sitting together. Okay? Sitting together. There we go. Okay, we have 48 arrangements of that. But wait a second, we're told we don't want that. So that's a negative thing, isn't it? That's an awful thing. That's a negative. Well, great. You know what we can do? Is let's figure out how many arrangements there are of everybody. Think about it. You've got 5 people at the theater. 1, 2, 3, 4, 5. We've got 5 possible seats. So 5 choices for the first one, 4, 3, 2, 1. And if you multiply all that together, you get a really nice number of 120. That's all the possible arrangements. But now what we're going to say is we don't want this. We don't want them together, but we know that there's 48 arrangements of that. Oh, okay, so that means I'm going to subtract the ones that I don't want. That's called the complement. So if you subtract that out, you end up having 72 possible arrangements where Anne and Eric are not sitting together. You see how it works? You put them together first, subtract it from the total, and you get what's left, which is 72 arrangements. Well, that's just too sweet. Okay, now, last one that we have to figure out. The last one is this one. Boys must sit together and girls must sit together. And we've done something similar to this before. So if the boys sit together, they're all going to sit on one side. There's the boys. Girls sit together. There's the girls sitting on another side. Okay, let's figure out how many boys we have and how many girls we have. Let's go back to the top. Right. So we have Anne, that's a girl. We have Diane, that's a girl. And that's it. So we have 2 girls. That must mean 3 boys. Sure enough. Brian, Colin, and Eric. 2 girls, 3 boys. Okay, let's answer the question. 2 girls and 3 boys. There's 3 boys. There's 2 girls. Let's go to town. Okay, so how many arrangements of boys can we have if we sit the boys on the left-hand side? Well, the first chair would contain 3, the second chair would contain 2, and 1 choice for the third chair. On the girls' side, we have 2 choices for the first chair, 1 choice for the next chair. Makes sense, okay? How about if we flip this around? Well, wait a second. 3 times 2 is 6 times 1. That's, of course, 6 choices for that. 2 times 1, we have 2 choices for that. Oh, yippee skippy. 6 times 2, we have 12 arrangements if they sit boys on the left, girls on the right. But I'm also curious then is what if the girls are on the left and the boys are on the right? Well, the arrangements don't change. There's still, for the girls, only 2 arrangements for the girls. And, of course, there's 6 arrangements for the boys. So 2 times 6 also gives you 12. I got a question. Is this an and or an or? Think about it. You can have the boys on the left or the boys on the right, which means you add this. So a total of 24 arrangements. Wow, that was cool. Stay tuned. More stuff coming up, including perms, comms, and factorial notation. Woo, woo.